Hey guys, welcome to another lecture from Introductory Statistics. We've already learned the concept of continuous random variable. Today, let's work on a question together. So suppose you have a random variable x with the following PDF. C times x squared, where c is a constant and x is lying between -1 and 1. It's 0 otherwise. What do we have to do? We have to find the value of this constant such that this is a valid PDF. We should try to find out the expected value and variance and hence find the probability x is greater than or equal to half. So let's do that together. Part A of the question, finding C. So what we know is that the total probability between -infinity to infinity, if it's a valid PDF, then the total area under this curve should be equal to 1, right? So therefore, between -1 and 1, since x is defined as 0 elsewhere, so between -1 and 1 is defined as cx squared. So between -1 and 1, cx squared dx should be equal to 1. So this means cx cube upon 3 minus 1 to 1 should be equal to 1. So therefore, this means, keeping c here, now putting the bounds, c by 3 is here. Let's put the bounds now. So 1 cube minus -1 cube is equal to 1. So therefore c by 3, and here you will get 1 plus 1 should be equal to 1, which means that c should turn out to be 3 upon 2. So that should be your C. That means your PDF actually is fx is equal to 3 by 2x squared, where mod x is less than or equal to 1. Hence, let's find out of part B. So let's try to find out the expected value of this random variable. So expected value is from -infinity to infinity, the integral x times fx dx. So the concept of expected value is exactly same as the discrete. It's the weighted average, but this time how will you find it out? You will use integrals because area is because probability is density now. So this will be equal to -1 to 1 x 3 by 2 could be kept outside into x squared dx. So it's going to be 3 by 2 x to the power 4 upon 4 minus 1 to 1. So this will be 3 by 2 into 4. And here you will have 1 to the power 4 minus 1 to the power 4. This time what's happening? Since you have 1 to the power 4 minus 1 to the power 4. Now, power is even, so this becomes 0 because this is also 1 and this is also 1. So you will get 0. On the other hand, now let's try to find out the variance. Variance for this random variable. Variance is expected value of x squared minus expected value of x whole square, right? So what we need to find out is expected value of x squared. Expected value of x squared will be -infinity to infinity x square fx dx, right? So fx is 3 by 2 x square dx. So that means I can keep 3 by 2 outside and it's going to be -1 to 1 because that's where our function is defined. So -1 to 1 x to the power 4 dx. So it's going to be 3 by 2 x to the power 5 upon 5 from -1 to 1. So 3 by 2 into 5, and here it's going to be 1 to the power 5 minus -1 to the power 5, which will actually again give you 1. So it's going to be 2 into 3 upon 2 into 5. So this cancels off. So 3 by 5 is your expected value of x square. Hence, variance is equal to 3 by 5 minus 0, that is 3 by, that's what will be your variance. Then the last part that I have in this question is to find out probability x is greater than or equal to half, right? Well, probability greater than or equal to half means that we'll be considering only x which are greater than half. So half to 1, fx dx, fx is 3 by 2, x square dx. So 3 by 2, you can keep it outside, and x cube upon 3 from half to 1. So this will give you 3 by 2 into 3, and here you will have 1 minus 1 by 8. In other words, you will have 1 by 2, 3 cancels, into 7 by 8. That is 7 by 16, which should be the correct answer. Okay. This is how you calculate. Whenever you have any continuous random variable given to you, always remember, if you're practicing, the moment you find any continuous random variable, you have the domain, you should try to find out at the least, first of all, if there is constant somewhere, just try to find out what that constant will be for that to be a valid PDF. Second thing, expected value and variance is something that you should definitely try to find out for practice purpose. Thank you very much.